Hey, hello you, Ken here. We're going to be working on a distortion pedal, Jimi Hendrix fuzz pedal, yeah. So enjoy the next however many minutes this film takes. Alright, doing a little test run here of the fuzz pedal I'm working on. You see the schematic, parts over it. Basic Hendrix fuzz pedal. Here's what I got whipped up on the board. My potentiometers I have currently hooked up to a bunch of alligator clip leads because it's just more convenient. I don't want to solder on them yet. Anyway, little test here. I got 12 volts going into the circuit. I got Zener diodes bringing it back to about 9-10 volts. Got some biasing potentiometers there, which I have adjusted properly, and lead guitar. So, just out of curiosity, some nice square waves. Turn down the gain a little bit, get it clean. Oops. I literally have everything hooked up to clip leads at the moment. Bring it all the way down, clean. What your average guitar would look like on a scope. Bring up some distortion. Damn that wire. Let's bring it all the way up. All the way floorboarded. Those beautiful squares. See the symmetry, I mean. A little bit fatter on top of the waveform than the bottom. It's the way a typical fuzz pedal of that era would work. My guitar's out of tune. Distortion a bit. Anyway, so far what I got on my bench. Right at 12 volts, I got. Actually, I should try this real quick too. Originally, what I was gonna do, I was gonna hook up. Definitely have to disconnect my amp for this. Just once again, all clip leads at the moment because I don't want to solder on to all this stuff until I get to that point. So we're going to disconnect the audio out jack. So all we see is what's on the scope when I pluck the guitar. We're going to disconnect the guitar, and we're going to hook this to my signal generator. See, I have this set to 1 volt. That's way too much. Let's see, amplitude. I want that to be like 100 millivolts. Sounds good to test with. Alright, hold up. Oh, that's ground. Okay, if all goes well. Well, should be getting a sinusoidal tone. What's going on here? Oh, I think I broke something. Shit. Let's see, we got this input. Why am I not getting nothing? Lose voltage. No. We lost output on the scope. That would make sense. It would help if I had the scope probe hooked up. Damn, it doesn't want to hold up. State. Alright. Okay. Positive lead. You can see the 60 Hertz ground hum in the background going through the distortion pedal that I'm currently working on. So let's hook this up to, let's see, 100 millivolts at 800 Hertz. And we got a hell of a square wave, very asymmetrical. It's about what you expect for a Jimi Hendrix fuzz. Let's see here, amplitude. Let's go down to, oops, hit the wrong button. 10, yeah. You can see it starts, we'll go all the way down to 1 millivolt. 1 millivolt starts looking like a sine wave. And we'll see where it starts distorting. It starts distorting on the top of the waveform, which is typical of a germanium fuzz effects pedal. So you got 2 germanium transistors there. Plop and plop, 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 plop. The little cans. So it looks like a sine wave. We're at 0.1 millivolt. Let's increase. Start going up. It starts distorting on top of the waveform first. So we have some asymmetrical waveforms going on, and it starts distorting on the bottom. How far can we take this? Let's see, let's go to tens of millivolts here. Alright, I think I lost video there for a second. Forgot this camera only does 8 minutes. We got our cups dead center, so we're using the middle. And we'll switch it down to these two. A little more generic kind of sound. And I'll just play for a second. I don't know how well this is going to pick up in the camera. Man, this camera sucks. Sucks. playing around a little bit. This is like not even all the way. Go all the way. Oops. Not trying to play real well, I'm just testing this. Hope you guys get the idea. So this is where I'm starting out here. Essentially gonna be built into this metal box. It's a Hammond box I got. Pretty thick aluminum. I mean, come on my thumb. The metal. Pretty thick. So it's gonna be a bitch to drill through and paint. Let's see what I got going here. Some dials. Thinking about using these. These were off a Marantz stereo, so that'll fit the potentiometers nicely. And of course, if I can grab it, the mushroom cup. The mushroom cup does not like me right now. And the other control, something like that. This is the output control. That's the fuzz control. I might chip this away so I can mount all three legs. I'm gonna have to cut this so I can mount the three legs of these germanium transistors. These germanium transistors are very hard to find. They haven't been made since the 60s and 70s. Let's get some better light on that. That's not better light, is it? Anyway, these are hard to find. I was originally going to use these transistors I bought from Amazon. These are 3AX31B. I thought these would be good, but I got a dud. This one's good. This one over here in my soldering bin, full of solder, is bad. This is going to have to hit the trash, my junk part drawer. So instead of soldering directly to the transistors, I might actually cut this and just mount them, because these old germanium transistors are not like silicon. You actually need to take very good care of how much heat you put on the leads, so you can destroy them very easily. But luckily I have a couple spares that I found, so we'll see how that goes. Really want to use this 5k ohm potentiometer for the fuzz effect, but I'm going to have to use this counterclockwise one. I don't know, clockwise, as a clockwise 1k ohm resistor, which means I'm going to have to turn it to the left to get more fuzz, which is the backwards way. There's no other way around it until I replace the part. It'll be fine for now, but that's all I can work with, because finding these potentiometers that are counterclockwise and logarithmic instead of linear, next to impossible to find. I can get linear potentiometers, 1k ohm resistors, but then this only like the last 20% that actually has anything going on. So I like this is more smooth sounding all the way up and down. I'll have to turn it to the left to get distortion. But I figure when I build the box, I'm going to have the dials on here. One will go forward for output, one will go backwards for fuzz. It'll be a little awkward, but I'm going to put some labels on there. Minus, plus, plus. So turn that, you know, it makes sense. Or no, it'd actually be positive, minus, minus. So positive, you turn this one at gain, turn this one gain, turn this one, and then, you know, if that makes any sense. So I hope you enjoyed this so far. I have a lot more video here to take of this project as I go along. It's going to be a long project here. Okay, I had a dumb moment. I was wondering why I wasn't getting signal out of the signal generator, and look at this. I connected it to the wrong connector. Duh. Gotta go to channel 1 output. Come on, there we go. So now we got a signal. Okay, there's our input. Let's change the seconds per division. A nice sine wave. This is putting out a sine wave at, you can see that, 100 millivolts at 800 hertz. Look at that asymmetrical waveform on the top. That's our output. I'm going to change the fuzz factor. Well, doesn't do as much as I thought it would. Maybe it's just overloaded. Turn this down. The amplitude. You wanna amplitude. Amplitude. You mother effer. Alright, we've got a 10 millivolts. It's more like it. Let's turn up. A little fuzzy, but we're talking about guitar signals and we got a lot of stray wires. Then we change. Now that's literally the fuzz control. As I'm turning it. You see how it changes the symmetry. I'm saying that word right. Let's go down to 5. Well, we'll go down to just the hair. Now you can really see where it starts to clip. That's at 2 millivolts, 3, 4, 5. Input looks staticky, like I said, because the wires are all dangling. We'll change the fuzz control. The fuzz. Ooh, look at that. That's low, and then you start climbing. It starts getting asymmetrical on top, and then towards the bottom. There we go. Now I got what I want to get on film. This is the guitar input, which is, like I said, staticky because all this chaotic wiring. On top we have our output, which is starting to look squared off, but notice it's not completely squared off. If you follow the waveform carefully, you'll see there's some drop and some roll. That's caused by the germanium transistors having a very specific effect on that tone. If this were silicon transistors, they would definitely have a very symmetrical waveform and they would not roll off or roll in like that. And that's what gives you that very specific tone with a Fuzz Face pedal, as far as I'm aware. So I hope that kind of completes this segment of what I was trying to take.